Hello everyone, welcome to the AI University, where we explore the latest advancements and trends in machine learning, deep learning and AI, as well as try to create new real-life based projects. I'm Nitin, your host, and I have come up with a new video series where we will be learning about object detection, which is very vital for self-driving cars. In this video series, I will start with a video where I will be letting you know about various steps involved in the model implementation in the self-driving cars, as well as giving introduction of object detection. Later in the video, I will give you the glimpse of V7 platform and its various features. The next video will be pertaining data preparation, where I will be showing you how to annotate or label the image data using bounding boxes as well as using auto annotation feature. In the third video, I will show you how to train object detection model on labeled image dataset, and then we will be moving to model testing and evaluation. We will do everything from scratch in a step-by-step manner using a platform known as V7 Labs. They have a product called as Darwin, which we will be making use of throughout the series. V7 Labs is also the sponsor of this video. Friends, I will share the link of V7 Labs platform in the description section so that you can take a look at it. So without further ado, let me start. Self-driving cars use a variety of machine learning models to perform tasks such as object detection, lane keeping, and decision making. One commonly used approach is to use deep neural networks or DNNs for these tasks. DNNs are trained on large amount of data such as images and sensors data from the car to learn how to recognize objects, navigate roads, and make decisions. Once the DNN is trained, it can be deployed on the car's onboard computer to make real-time decisions as the car is driven. Additionally, self-driving cars also use other models such as decision trees, random forest, and support vector machines for different purposes. Since object detection model is one of the models that self-driving cars incorporates, so let me tell what exactly it is. So object detection is a computer technology related to computer vision and image processing that deals with detecting instances of semantic objects of a certain classes in digital images and videos. These classes can be cars, stop signs, crosswalk signs, speed limit signs, traffic lights, buildings, roads, intersections, and even vegetations. Object detection algorithms typically leverage machine learning, deep learning, or computer vision techniques to produce meaningful insights from images and videos. Object detection can be used in many other applications as well, such as surveillance system, robotics, augmented reality, satellite imagery analysis, etc. So let me now talk about the steps involved in the object detection pipeline, and more specifically the steps involved in building and implementing these object detection models in self-driving cars. The first step in building deep learning model for self-driving cars is to acquire large data set of images and or videos that will be used to train and test the object detection model. This data can include images of cars, stop signs, crosswalk signs, speed limit signs, traffic lights, building roads, intersections, and even vegetations. Then there is LiDAR, which is light detection and ranging, which is nothing but a remote sensing method used to examine the surface of the earth. And then there is a radar sensors data and information about the car's speed and position. The next step is data pre-processing. So the collected data is then pre-processed to remove any irrelevant information, correct the errors, and make it suitable for model training. The data set should include a set of labeled examples of objects you wish to detect, with each of object instance marked with bounding boxes. If you don't have such labeled or bounding box data, then we can use platforms like V7 Labs to annotate the image or video data. In the upcoming videos, I will show you how to draw these bounding boxes seamlessly with the help of V7's Darwin platform. The next step is the model training. So the pre-processed data is used to train a machine learning model such as deep neural network, and in our case, it's object detection model. The model is trained to recognize objects, understand a road layout, and make decisions based on input data. In this step, you either choose a pre-trained object detection model that you will fine-tune for your use case, or train your own object detection model using a suitable framework from the scratch. Now here also I will show you how to use Darwin, that is V7's Darwin platform, to train an object detection model. Before moving on to next step, I would request you to consider subscribing to our channel in case you haven't subscribed yet, and press the bell icon and turn on the notification so that you can get informed of any new video related information. So the next step is model validation. The trained model is then evaluated on a set of validation data to ensure that it can generalize well to new situations and has a reasonable accuracy. This process is important because it allows practitioners to understand how well the model is able to generalize to unseen data and to identify areas where the model may need to be improved. So the next step is model deployment. Once the model has been validated, it can then be deployed on the car's onboard computer. This allows the model to make real-time decisions as the car is driven. Here are the steps that are used for model deployment on car's onboard computer. So in this particular step, there are several sub-steps. Number one is model export. So the trained machine learning model is exported in a format that can be read by the onboard computer, such as TensorFlow or ONNX. The next sub-step is onboard computer setup. So here the onboard computer is configured to run the deep learning model. This includes installing any necessary software libraries and dependencies. Then the next sub-step is model integration. So the exported model is integrated into the onboard computer's software system, which is responsible for controlling the car's movement, such as steering and braking. The next sub-step is sensor integration. Here the onboard computer is connected to car's sensors such as cameras, lidar, radar, GPS, and other sensor data is fed into the model for predictions. Next sub-step is real-time processing. So the onboard computer processes sensors data in real time and uses the machine learning model to make decisions about the car's movement. Next sub-step is safety mechanism. Here safety mechanisms such as fail-safe modes are implemented on the onboard computer to ensure that car can safely stop or take other actions if necessary. Then the next sub-step is testing. Here the onboard computer and machine learning model are tested in various scenarios to ensure they work correctly and safely in a real-world environment. And then the next sub-step is deployment. So once testing is completed, the onboard computer and machine learning models are deployed on the self-driving car. The car's software and hardware are updated to the latest version. And the final sub-step is monitoring. So here the car's performance is continuously monitored and any necessary updates or maintenance are performed to ensure the system is working correctly and safely. So let me now show you the V7 platform and some of its modules. First, we have dataset module, where you can create the dataset of your images or videos. You can see here that I have created few datasets already, right? Such as miscellaneous, signature objects, road signs related data, vehicle, etc. So I will be showing you how to create the dataset in the later videos. So let me click on the miscellaneous dataset once. So you will see images related to stop sign, traffic signal, speed limit, etc. here that we will be using for model training. If I click on, let's say, this image, you will see a bounding box around the stop sign. I will be showing you how to annotate images and create bounding boxes around the objects in a given image. So let's go back and see what's the next module is. So the next module is workflow. So if I click on this basic workflow 2 here, you will see some kind of end-to-end. So let me minimize it. So we'll see, kind of end-to-end data pipeline showcasing different stages associated with annotation. So in the first stage, we have our traffic sign data set. But in your case, this data set can be anything else, right? And these images are generally unannotated images. Now the second stage is annotation, where we move further and create bounding boxes around objects in a given image. Treat this stage as a developer stage. Now the third stage is review, where the annotated images gets reviewed by quality assurance team. Let's say one of the developer creates a bounding box around a stop sign and marks it as traffic signal, which is wrong, right? So QA team can see this error in the review phase, and then after reviewing they can mark it as rejected, right? They then send it back to the person who wrongly annotated the image. That's why this arrow is going back here. After correction, the image gets accepted, followed by next stage, which is complete. So this is the workflow module, where you can create several workflows, not only related to annotation but also related to the model training. The third module here is classes, where you see different classes associated with the annotation. If you see here, you will observe that I have created different classes associated with objects such as stop sign, crosswalk, speed limit, etc., which I can observe in a given image when we create the bounding boxes. These classes are nothing but labels that we create around bounding boxes. Next module is model, where you can train the object detection, classification or segmentation models on your given data set. These are all deep neural network models. More on this in the later videos. The next module is annotator, where you will see your data set progress. So if you scroll down, I have this miscellaneous data set, and you can see the data set progress and the people or annotators who are working on the data set. It will give you a glimpse of how many images are in approved stage, how many rejected by whom and on which date. So you can see complete progress here. Friends, the next module is community support module, where you can participate in the model training annotation related discussions with the V7 community, right? You can see here. Let's go back. Then we have this academy module. So here you can go through V7 annotation related videos to learn how you can build AI with V7. You can find all sorts of learning videos here. Friends, next module is documentation, where you can find details around documentation associated with annotations, neural networks, Python libraries, PyTorch, video guides, etc. Finally, in the settings section, you can update your profile as per your need. So folks, this is it for this video. In the next video, I will cover the data preparation stage, where I will show you how to create bounding boxes using V7's Darwin platform and plug it with the workflow pipeline. So stay tuned. Don't forget to subscribe and press the bell icon, as it will help you provide notifications of all the upcoming videos. Thank you folks.